Now in this session of video we are going to discuss class 12th maths invertible function. So we have already discussed about the function. Now in this session we will discuss invertible function, or also called, actually it is inverse of a function. Clear? First we will understand the definition. So the definition is a function f x to y, x is a domain and y is a codomain, is defined to be invertible if there exists a function g. Clear? Y to x. In this case, y is the domain and x is a codomain, such that if we find the composition GOF, so we get identity function IX, and if we find FOG, the composition of function, then we get IY. Clear? So it is clear we have a function from x to y. If there exists another function, so another function is what? G, from y to x. Clear? F is a function in which x is a domain and y is codomain, and g is a function in which y is domain and x is codomain. Then g is said to be a inverse of function f if it complete the conditions that if we find GOF, composition of g with x, we get ix, and FOG, what we get? IY. The function g is called inverse of f, and g is denoted by f inverse, f invertible. Clear? Okay, some important things to remember. We also, f is invertible then to the inverse of a function f is exist if and only if f must be 1 1 and onto. Clear? Then we said if f is there exists a 1 1 and onto of this function f, then we said to be a f is invertible. Clear? And conversely, f is 1 1 and onto, then f must be invertible. If you prove that f is 1 1 and onto, then we can say that f must be invertible of function. Clear? So if f is invertible, then it is obviously 1 1 and onto. And if you want to find out or prove that f is invertible, then you have to prove only that it is 1 1 and onto. Clear? And another way to prove that, find GOF and FOG. Clear? Now we go for the algorithm how to prove that the function is invertible. For that, first of all, suppose that we have function f a to b defined as fx is equal to anything, any expression in terms of x. Clear? Step 1, we have to take a function, arbitrary function from set B. Set B means from this B is codomain. We have to find any element from codomain and put up is equal to, we know that obviously y is equal to what? Fx, and then solve this in terms of x to get y in terms of x. Clear? So now we, after that we are putting the value, we find the x in terms of y. Clear? Then when we get the y in terms of x in terms of y, then we get a new function, and that function is b to a. F is a to b. When we get a function x in terms of y, clear, then we get another, then we can say there is exist another function g, b to a, and gy is equal to value of in terms of x. That is the new function we get. Clear? The next step, what we have to done, we have to find GOF and FOG. Clear? So quickly we revise the step. First we have to take element from B, solve these elements. Clear? And to find x in terms of y, then we said there is another function g b to a, and such that gy is equal to this in terms of x, then we find FOG and GOF. Clear? If we find, to solving that, FOG, if we find FOG is equal to IX and GOF is equal to IX and FOG is equal to IY, then we can say that what? It is an invertible function, otherwise not. Clear? To understand that, now we are going to solve this question. What we have to give in? First of all, f is any function n to y. Clear? Natural number to any set. Be a function defined as fx is equal to 4x plus 3, where y is equal to the function y. It is a set of natural number and y is containing the elements of y such that y is equal to 4x plus 3 and all x belongs to natural number. Show that f is invertible and find the inverse. Now what we have to prove that? We have to prove that f is invertible function. Clear? So we go for the algorithm. First of all, we have to write down in solution fx we have given. What is fx given? 4x plus 3. Clear? Now according to algorithm, what we have to done? We have to write down y is equal to fx. Let y, small y, is any element belongs to this capital Y. Clear? Next we know that we have to done this fx is equal to y. Clear? Further, y is equal to fx. Now what is the value of fx? Fx is equal to 4x plus 3. Clear? Now we have to find the value of x in terms of y. So for that, what we will done? We will substitute y minus 3, x is equal to y minus 3 upon 4. Clear? Let it equation first. Okay. Now what? We have to find out a new function. Let g is a function y to natural number. Clear? Okay. Now what we have to done next? Gy is equal to, new function is what? Gy is equal to y minus 3 upon 4. That is one new function. Now next step, we have to find GOF FOG. Now we will find that GOF x. GOF x. So we know that GOF can be written as G fx. Further, now put out the value of g, this fx. What is fx we have given? G, and the fx we have given 4x plus 3. Clear? Now gy we have given. Gy, what we have? Y minus 3 upon 4. So in terms of y, we have to put up this value. So what we have? 4x plus 3 minus 3 upon 4. Minus 3 upon 4. So it is cancel out. 4x upon 4x. So now GOFX, what we have get? X. It is called identity function IX. Next, what we have to find? FOG. FOGY. So now FOGX, what we have? FOGY. FOFGY. Now GY we have GY. The value of GY is 4y minus 3 upon 4. Clear? Now put up this value into fx. fx we have now. Fx we have given fx is equal to 4x plus 3. Now in terms of x, what we have, this is value. So in place of x we will put up 4 into y minus 3 upon 4 plus 3. So it can be written as y minus 3 plus 3, it is cancel out. So what we have given, y. So FOG y, we are getting y. So that is IY. So finally, what we get finally? Finally we get FOG y is equal to IY and GOFX is equal to what? IX. Hence F is invertible function and G is inverse. G is a function from y to n and GY is equal to what? GY is equal to y minus 3 upon 4. That is the inverse of a function f. Clear? Now